This is ARMAN KUSHAIRY bin ASWANDI. My matric number is B0920100405.
My name is Muhammad IRFAN DANIAL bin HEIDIZANI. My matric number is B0920100077.
My name is NAJIHA binti JUSRI. My matric number is B0920100096.
My name is ZARIF IKRAM bin ZAKIR, matric number B0920100366.
My name is DANIAL and my number matric is B0920100281.
Hi, Assalamualaikum. My name is NAJIHA binti JUSRI MENIN with matric number B0920100096. So I will explain about the drawing process for this lab. And the first step is I will take ZX plane as the reference plane and I will start drawing. I will start to draw the cut sections of the disc brake rotor without any proper dimension yet, just roughly without any constraint or value. Then after that I will apply constraint on every side of the drawing. Then I change the value of the drawing of the constraint. I change the value of the constraint with the proper dimension according to the lab sheet, and I have to ensure that every side of the drawing have a constraint so that I can continue with the next procedure. I have to ensure that the value of the dimension that I use for this cut section is correct according to the lab sheet. After that, I will go back to the plane and apply shaft command to form a solid body of the disc brake rotor. And later, I will go back to the brake drawing and I will form a circle for the hole of the nut. And I will apply constraint according to the proper dimension in the lab sheet. I have to ensure that the drawing that I draw have a constraint, a proper constraint that will turn green. Then I can continue with this the next procedure. Then I use pocket definitions of command to make a hole, and I will use ground command to form 5 holes in a second. After that, I will go back to the drawing and started to draw the brake pad. There is no exact value of the brake pad dimension in the lab sheet. But I have to make sure that the dimension that I use is was in the range of the dimension that I've stated in the lab sheet. And I will apply constraint on every side of the drawing. And I will change the value according to the proper dimension. After that, I go back to the plane and use pad command to form a solid body for the brake pad, and I will continue the same procedure for the other sides of the rotor for the brake pad. And I have to ensure that the dimensions of the sides of the brake pad is the same with the other sides. Then I will use the same pad command and then I'm finished to draw the solid bodies of the disc brake. That's all, thank you.
Before we start the analysis, we need to apply the material, and the material chosen is iron, and ensure that the properties of the iron is correct, and to specify on what type of iron desired, we can change the properties value according to the type of iron that we want to specify. So to start the analysis, we need to start clamping the center of the brake rotor. Then we need to apply the sliding force on the both side of the rotor. Later, we need to apply distributed force on the brake pad area with the value as stated in the lab sheet. Next, we need to apply rotation on the brake rotor before we click compute. Then, select frequency case with the static case solution as the reference and compute. And then, the analysis is running and record the data. As the static case, the force will only apply in the brake pad area while it's not moving, and as you can see, it's breaking apart. Next, we'll look on the von Mises stress on the rotor, the maximum value and the minimum value.
Good morning. My name is Li Ihang and my group member is ARMAN KUSHAIRY, NOOR NAJIHA, DANIAL and ZARIF IKRAM. So now we're gonna present the lab 1 design and analysis disc brake. Okay, so for the first topic is data finding. Okay, so the first properties, Young modulus, the value is 2.11 times 10 power of 11 and the unit is n per m square. So for the second one, Poisson ratio, the value is 0.27 and the number 3 is density, value is 7870. The unit is kg per m, power of 3. And the number 4 is thermal expansion, value is 1.21 times 10 power of negative 5. So the unit is k, power of negative 1. So number 5 is yield strength, the value is 3.1 times 10 power of 8 and the unit is n per m square. So the last one, material name, the value is iron. Okay, thank you very much.
And for the experimental result, the maximum value of the displacement is 275 mm and the minimum displacement is 27.5 mm with the frequency of 973.66 Hz. The maximum and minimum displacement is distributed circularly on the brake disc rotor as the brake pad force is applied while it's moving. And the maximum von Mises stress of the rotor brake is 3.12 multiplied by 10 to the power of 11 Newton per meter squared, and the minimum von Mises stress is 9.26 multiplied by 10 to the power of 8 Newton per meter squared with the frequency of 973.66 Hz. As the rotor is moving in a circular motion, the von Mises stress is distributed at the center of the rotor.
My name is Muhammad IRFAN Daniel bin HEIDIZANI with matrix number B0920100077 and I'm going to explain about the factor of safety. So the formula for the factor of safety is the ultimate stress divided by allowable stress. So the value for the ultimate stress is 3.1 times 10 to the power of 8 Newton meter squared, and the value of allowable stress is 3.12 times 10 to the power of 11 Newton meter squared. So after calculating the value, we got 0.001. So the factor of safety is less than 1, which indicate the design is not acceptable.
My name is ARMAN bin ASWANDI and my metric number is B0920104005. And today I'm going to continue the discussion for this lab. Von Mises stress is often used in determine whether an isotropic inductor metal will yield when subjected to a complex loading condition. In this lab, we use iron for the disc brake rotor material. The value of maximum von Mises stress that we got when running the analysis is 3.12 times 10 to the power of 11 Newton per meter. And the safety the safety factor of this design is less than 1, which means that the design is not safe. We need to change the design or use the suitable material that can afford the stress if you want to remain the design.